Well, hello everybody, and welcome back, and welcome to our next installment of viewer questions, comments, and answers. So this month here is going to be wow. I either have to really thin the herd on these comments, or this is going to be a really long video. Probably got about 200 comments this month since the last one, which is great. I read every one of them, and I appreciate everything that you guys have to say. So I will try to, like I did last time, I'll try to clump them together as best as I can, and I'll try to address everyone that I think needs addressing. Some of them were just kind words and comments, and I really appreciate those. Believe me, I read them, and believe me that I do appreciate them. So thank you all so much. So let's jump right into this so that we can start answering some of these questions. First one I have was a viewer asking, let's see here. Nice work. I was given an STA64B that's not working, and is this something that would make a good platform to learn how to repair? Well, in order to answer that question, you have to kind of answer that question with some questions. So the first thing you kind of want to ask yourself is, what is your current skill set with electronics? If you have already done some electronics work and you currently have some experience with that, like especially working maybe on small radios and things like that, then, and you're trying to now start to kind of move up into receivers, stereo receivers and things, yes, then in that case, yes, I think this would be a great learner, a great learning tool. I have in front of us the schematic for the STA64, the realistic. It's a Radio Shack. It was one of their lower end ones. It's only rated at 16 watts per channel, and it has a lot of the design characteristics of a typical 1970s and 1980s era AM/FM stereo receiver. Once you learn kind of the building blocks of how they put these together, then you start to see the similarities even in the higher end units. When you get to the big 120, 150 watt per channel, you'll find out that there's a lot of similarities to these simplified ones. Just more transistors and bigger power supplies and things, but really the concept of troubleshooting is still there. So yes, it would be a very good one to learn. There's really nothing strange, out of the ordinary. It has a integrated circuit multiplex circuit. It has a FET preamplifier, or F amplifier. Has your basic sections that you can break down, for AM and FM, and your IF stages. It's all there. For the amplifier, you have the preamp and the tone section and the output amplifier section, the switching and the power supply. It's all very modular, very easy to identify the components and work on. And Sam's Photo Fact does make a document for this, and it's document number 31-2073. So that's a good thing, because it's a pretty good documentation on these. Now expect to spend upwards of $20 or so to get the downloadable print version of this. It's not cheap. A lot of times you get the receiver for free, or you get it for $10 or something, and then you end up spending more on the service manual. I really searched online, and I could not find a reliable copy of the service manual for this. So I really wanted to do an STA64, and if you look at my video, I kind of explain a little bit why. So to me, it was worth making the investment. There's a lot of them out there on eBay, and I have the feeling that sooner or later I'll get some more of them on the bench, so I'll put this to good use anyways. But it's also a good learning tool. This is a teaching tool. So when you spend this, you're paying for an education. That's how I look at things like that. Knowledge is a good thing to acquire. You're not wasting your money on knowledge. So yes, I guess I would say. Now, if you're somebody who's just getting into electronics, this is not a good idea, because there's a lot of things you need to know up front before you start working on any receiver. I would suggest starting small, like AM radios, mono type thing, that's small. The little transistor ones. Tube radios are very good to, big parts that are easy to access and work with. But you have to be very careful working with any tube gear because of the high voltages and things. And you need to learn about that. But I would definitely start with radios or small thing, or just small amplifiers, things like that, before I would really get into a receiver. So I hope that answers your question. Okay. So let's look at some other questions here. All right, the next one that we have here that I'm going to go over is a really good question. How can I break down the part numbers of IF cans, or the IF transformers that you see in radios and things like that? That's what he's talking about. And it says, I've looked everywhere to try to determine just what the specs are. Well, that's a really loaded question. So the first thing I want to do is kind of show you a little bit that there are some online resources. Here's one that I'm going to give you for an example, and it's called junkbox.com. You can see up there, junkbox.com, electronics vintage data sheets. Okay, and really neat little website, and they're talking about these transformers, and you can see them. You can see up here the couple different examples that they have. And if you look at the name Miller, you want to kind of look at that, because Miller, J.W. Miller, was one of the more common manufacturers of IF transformers, and all the different oscillator transformers and antenna coil transformers, all that. And they made a whole series of replacement coils, and they made a lot of the coils in transformers that you see in a lot of the old radio gear. Okay, now there were lots of other ones too, but this is just one that you can look. And this site is pretty neat because they have scanned a few of the old documents you can see. And for instance, I opened up this one on another page for the 455 kilohertz transformers. Okay, so if you click on it, they show you what the transformer looks like. They show you what the schematic inside, and most importantly, they even show you the value of the little capacitors that are inside. Okay, any of you that have worked on these things kind of know what I'm talking about. Okay, so inside these little transformers, you have your coils wound on a on a cardboard form with a little ferrite core in the middle, and on the bottom you have these little stacks of very thin mica wafers that that make up the capacitors. Okay, and a lot of times those little mica wafers will pick up the silver off of the silver coating off of the metal contacts, and it will ruin those mica. They no longer become an insulator, they become a conductor. And we call that silver mica disease, or silver migration disease. And a lot of times we have to repair these coils or replace them. And they can be repaired. And I think I did go over that on one of my early radio videos, but I have 6 or 7 radios I picked up for time waster projects, so I'll probably do some of that in the future here. But it shows you the pinouts and so forth. So, that's one way to do it. The other way is, you can look up the part numbers, and a lot of times, if you know the manufacturer of the radio and you look on the can itself, you see like the little metal housing there, they'll actually stamp the part number right on it, or they'll put a little paper tag, as long as it's not worn off, with that on there. Now, as you're working with these more and more, you'll start to be able to kind of know what they are. just because again, just like we talked about on the last question, there's a lot of similarities between all the designs out there. But if you look over here, here's a scanned list of the common replacement transformers that Miller made at the time, and you can see they tell you the part number, they tell you what frequency it tunes to, and then it kind of tells you, some of the characteristics, what their bandwidth is, meaning what pass band it has at that frequency. These are obviously used for intermodulation because they're intermediate frequency. The intermediate frequency on these old radios is 262 kilohertz. The later radios were 455. There's also 445. You can see they used different frequencies for your intermediate frequency. So anyways, this is one of the ways to do it. And you'll see that even if it's not made by Miller, a lot of these transformers are interchangeable. They have very similar component values in them. But one word of caution that I'll give you going back to this one, just because you look up a 455 kc IF transformer and you see that this one has 107 picofarad and this one's 89, don't automatically assume that every 455 kilohertz transformer is going to have those same values. Okay, it's really important to try to measure the value or find documentation with the value. Now there are other ways to try to determine what the characteristics of a transformer are, but it involves some testing, and you need some test gear. You need a relatively good signal generator, and then you either would need a really good oscilloscope, or better yet, a spectrum analyzer, and then you would be able to attach, pass a frequency through the transformer, by, for instance, you could take and connect your signal generator across the input here, okay, like between pin 6 and pin 4, and induce a frequency on there, and then attach your spectrum analyzer or your oscilloscope to pins 1 and 2, okay, and quit doing that. And then you can actually go in and vary the frequency that you're driving into it, and you can actually watch where that frequency will peak on its output. In other words, when you hit the resonant frequency of that coil, the actual output will peak. It'll have its maximum amplitude, and at least that can give you an idea of what that coil tunes to. And even if it's out of tune, if you see one and it's peaking at in the 400 kilohertz range, let's say, that most likely that's a 455 kilohertz or 445, something like that, transformer. And it might be out of tune or something, being out of circuit, but at least you'll get an idea of the purpose, and you'll know that that's an AM IF coil. If it's not tuning at a low frequencies, let's say it tunes at 10.7 megahertz, for instance, then you kind of know that that's going to be for an FM receiver, for intermediate free, IF for for the FM. So I don't have any of these coils handy right now, but maybe I will scavenge one from an old radio when I get a chance here, and maybe we'll do a little follow-up video of how to test them. That might be an interesting thing, but those are the two ways that you deal with it. There are lots of things, Google search is your friend on this, and a lot of times with some of the manufacturers, like when you're dealing with Philco and Zenith and some of the bigger names like that, a lot of times they'll actually have a listing somewhere that you can probably go through Google search and find in the archives the characteristics of one of their coils. And a lot of times you'll be able to go to this Miller catalog and convert it to a Miller part number, that will be a good replacement. I don't have one right in front of me, but if you do a Google search, I have downloaded in the past, I think I have it somewhere on my computer, an actual full catalog of Miller transformers, IF transformers and things. And it's, pages and pages of different versions that you can look up. So I hope that answers your question for that. That's that's how to do it. It's not easy, but that's how you identify them. You can't always you can't always just look at it and know what it is. A lot of times you have to look at the part number stamped on the can itself and then try to convert it over based on the manufacturer, and hopefully they have some info on it in the service manual for it. All right, so let's look at our next question. Okay, so I've got tons and tons of, not questions, but comments, and I just want to address all of them in one bunch. So many different comments on the old married couple, the SA 9100 and the Pioneer TX 9100, the tuner and amplifier. And wow, I never realized how many comments that would trigger. So many people, it brought back memories of, gear that they had that was from that same era, from that same manufacturer, SA 7100s and 8100s and all these different things. And you all shared some really wonderful stories, and I encourage all of you to go through some of the comments on those two videos and just kind of look at them, because it's pretty interesting stuff. So I really appreciate those comments, and that's kind of the reason that I do this. I really enjoy reading what you all have to say. I learn stuff, and I'm a history buff. I love to learn about historical things, especially with electronics and things like this. So to hear people's stories of the past, the things that they've had, and the experiences they've had with what you all had with this equipment and stuff, it's really cool to learn. So thank you again. Thank you so much. And like I said, I direct that to all of you who left me the wonderful comments. Okay, the next question, actually it's several questions that I've had concerning the video I did on the Rubidium frequency standard. And a lot of them basically are asking, can you take it apart and show us what's inside, because it sounds interesting, it's an atomic clock type thing, let me see it, Well, first of all, the model that I have is not really conducive to taking apart without possibly damaging it. So I probably will not take it apart. I have not taken it apart, and I probably will not take it apart. The other thing I'll say about it is, you notice it's disconnected right now. I do believe that this thing is faulty, and I think it was faulty when I got it. At first I didn't know it, but as I got a little more accurate test equipment to connect to it, got around to actually doing a little more accurate measurement, I'm finding that this Rubidium frequency standard is not very standard. It definitely has drift. It's not very obvious drift if you connect it to a less accurate frequency counter or something like that, but when you really start digging in on it, with a spectrum analyzer or something like that, I'm finding that it's not very accurate for what it's supposed to be, and that I have other signal sources that are every bit as accurate as this, and that's not the way these are supposed to be. And I think this one's faulty. It's I think it's been like that. I know that these have to run and get to an ambient temperature for a while before they will stabilize, but one of the reasons I purchased this model is that it was supposed to have been pre-calibrated, and it was supposed to have been customized to be a good 10 megahertz standard. What I've noticed is all the ones that I've worked with in the past that I've seen, I'm not an expert on them, but when you turn them on, that lock light doesn't usually come on right away. It usually takes a few seconds anyways for it to kind of lock in. This one, as soon as you turn the power on, the lock light comes on immediately. And I do know a couple of the internal regulators were disabled to make it more conducive of, bench work. But what I think has happened is in their doing that, I think it destabilized it, in the high parts per million range. So I'm going to have to do a little more experimenting with it. But as far as taking it apart, I'm not really comfortable doing that with these because they're very, very tightly packed together. There's things in there that's very easy to damage if you don't know what you're doing. So sorry about that, but that's about can't take it apart. The next set of questions are really interesting, and I think I caused a lot of confusion with that part of the video in the SA9100 amplifier video. And part of it was my fault because I literally hit the stop button instead of the start button for recording and cut out probably the most important part of the troubleshooting of the protect circuit. And so I don't know how clear I was. I know I put in a verbal description of what I did, but I don't know how well I got through to everybody. So I just thought I would go back through and give a little better explanation of what went wrong when that, why we were seeing the power supply having all that ripple, and why the protect circuit was not working properly. There was a couple reasons, but after I explain this, I think you'll have a full understanding. So in front of you, you see a schematic of the protect circuit for the SA9100. And if you look to the right here, you see the actual relay, and that relay is what cuts the connection to the speakers. Okay, so if you were to look at the contacts of that, it's actually in there to protect the speakers from any stray DC. So if something shorts out and you're going to put DC on your speaker terminals and possibly damage or destroy your speakers, this circuit is designed to sense that and to drop that relay out and thereby cut the connection between the amplifier and the speakers. So we're not really going to worry about how all this works right now. So basically all this is over here is that's your DC detect circuit, and it sets up your threshold for tripping the circuit and everything. But what we're really interested in is what was wrong. And I have to kind of start at the end and work my way back because I came into the middle of this problem, not at the beginning of it. So when I received the amplifier from the owner, he had already had it to a shop, and they attempted to make a repair on the amplifier, and he never really knew what it was they did, but he just knew that the protect circuit was not functioning properly, and when he got it back, it still wasn't working properly. And as time progressed, it got worse and worse till it wasn't working at all, and it was never coming in. So let's start with what I found. Okay, what I found was that two of these transistors were leaky. And what I mean by leaky is that they no longer are a semiconductor, they're acting more like a resistor. So even though the transistor elements would switch somewhat, they had DC resistance to them because they were partially shorted. They were failing. The components were bad. They were faulty. And because of that, since a silicon transistor is a temperature sensitive device, it was very unstable, so it was acting like a load on the power supply that was coming in, that plus 35 volts. So that plus 35 volts was going all over the place as these two transistors were leaking. Now, we're going to get a little bit more into that here in a minute, but to explain what I did was I replaced those transistors, and it got rid of the power supply issue because we got rid of the leaky transistors. But the protect circuit still did not work properly. And the reason it didn't work properly is one of these resistors in here was replaced with the incorrect value. And I believe it was, we'd have to go back to the video, but it was like, I think this 8.2K or something like that was actually reading, somebody had replaced it, whoever did the repair, replaced one of these resistors in here with a much larger value. Okay, maybe it was the 680K. I can't remember, but the whole purpose of actually I think it was the 68K here, and they had replaced it with like 180K or a 360K. It was a real high resistance. And what was happening was, this is a time delay circuit. So when the machine turns on, this resistor network charges this little capacitor slowly, and then after a little time delay of a couple of seconds, this transistor biases and brings in the relay, and as long as there's nothing in this circuit telling it to stay off, okay, this thing will turn on after a delay and bring the speakers in, and that prevents you from getting speaker pop when you turn the amp on, and it also allows the amp time to power up and get everything settled before it puts DC on the speaker terminal. So kind of like it's a protect circuit. Now I had to figure out what was wrong. So obviously somebody had worked on this circuit before to replace that resistor. You could tell it didn't belong in the machine, and one of those transistors looked like it may have been replaced or worked on in the past as well. So it failed again, and even before it failed again, it had an issue, that it wasn't working properly. So it took me a while to figure all this story out, but let's go to the very beginning now. What caused this protect circuit to fail in the first place, which caused the other company to have to service it in the first place, okay? Because really, if you just restore this to its original design, chances are you're probably going to see it fail again. This is actually, there's a mistake in this design, and we made a correction to it so that would not happen anymore. But the first thing I want to do is I want to explain what that problem is, okay? So what I've done here is let me bring you in focus here. Well, this is about as simple of a circuit as I can come up with. So all you have is a relay, and I have my power supply, positive and negative, and across the relay coil, you can see, I just have my oscilloscope connected. So here's my scope probe, and you can just see. So basically when I connect the power, you can hear the relay kicking on and off. Now what I want you to look at is the oscilloscope, and we have the oscilloscope set, and this is where a digital storage oscilloscope really shines, okay? It's going to allow us to capture a pulse, and we're going to be able to see what we're talking about with these high voltage spikes. Now notice I'm set at 100 volts per division. This is only a 12 volt relay, and I'm only putting 12 volts across the coil, so really there's only 12 volts here. But I want you to see what happens on this relay when I start opening and closing it. Take a look at that. 100, 200 volts positive going, and 100, 200, 300, 350 volts negative going. That's a noise spike, and we're only at 40 microseconds per division, so this is only going on for microseconds, millionths of a second. However, look at how much voltage. Now once again, remember the tiny little transistor right here. These transistors are only good for about 40 or 50 volts maximum. Most of them are 30 volt transistors, not 350 volt. And watch, each time I do this, look at that. Just craziness. Now that we know that that's going on there, we're going to take one of these, which this is a just a high speed switching diode, a 1N, I think this is a 1N4148, and all I'm going to do is put it backwards. You can see with the stripe pointing towards the positive. I'm going to put it backwards across our circuit there. Okay, that's the only change we're going to make, is just that little diode. And watch what happens when I turn this on and off now. It's not even triggering. I'll clear this off and watch. Nothing. Absolutely nothing. And if we go to our trigger and we put it in what's called untriggered mode, you'll see I am in fact having a signal there, but no noise spikes. Okay? Now let's think about this for a minute. Let me turn the light back on. We have a circuit here, just like where this little transistor is functioning just like when I was touching this. See that? When I was turning this on and off. This is the transistor, right? The transistor is acting as a switch. And every time that relay changes states, this is an inductor, guys. You actually have a coil of wire wrapped around a metal core. You have an inductor. That inductor has to release its energy anytime the voltage changes on it, okay? And it's going to release its energy through whatever path to ground it can find. Now, if I put 400 volts or 350 volts across this little transistor enough times, it's going to eventually cause it to fail. But what if I do this? So what's happening is the positive is up here, negative is down here, okay? This is positive voltage. Anytime this releases its energy, okay, it's going to want to release it in the backwards direction. We call that back EMF, or back electromotive force. But since this is this acts like a short in reverse bias, so when this thing goes to release its energy, it's going to redirect through this diode and straight back up to the top of the coil and basically short itself out. That's what that relay does. That's why you see diodes across a relay coil like that, just for the reason I was showing you. Now, the fact that this does not have this, every time that protect circuit is energizing and de-energizing, it's putting that back EMF right across this little transistor and causing it eventually to break down and fail. And this is what's happening. And believe it or not, I've had more than one person come to me with this generation of amplifier with the protect circuit not working. And this is why. Okay. Now, this is the first time I've seen another service company replace one of these resistors with the wrong value, and I have a feeling maybe they thought that the machine wasn't having enough time to power on, and there was a surge current or something when the amp was turning on that was causing this to fail. And I think maybe the thought process, and I'm just guessing here, I don't really know, but really what it was this back EMF. So if you remember on that video, what I did was I installed that diode across there after I finished rebuilding all this and repairing it. And I can pretty much tell you that I doubt that this transistor will ever fail again, and that's why. So there you go. Number one, you got to see the actual effects of not having that funny little diode on the relay that you see so often in these circuits. And number two, you got to see how a digital oscilloscope stores a waveform. Okay, so I hope this answered some of your questions, because definitely I think I caused a little bit of confusion with that video, and hopefully this clears that up a little bit. And anytime I see this on a protect circuit or on any relay circuit where a transistor is switching a relay, if I don't see this diode in here, you can bet that I'll add one in there, okay, unless there's some really good reason not to. So yeah, just thought you guys would be interested in that, and I hope that clears the water a little bit, or clears the air a little bit, with what that is. Okay. One last little addition to that. You may be tempted to use a standard diode, like these 1N4007s, and I just dropped one. I think it fell back in there. These little 1N4007s, they're rated at 1,000 volts, all that good stuff. But a lot of people will say, well, if there's 300 volts there, you need a diode that can handle higher than 300 volts. Well, the truth of the matter is, when that is shorted across there, the voltage never will build up over the 12 volt power supply that's on there, for the most part. So really it doesn't have to be that incredibly high of a voltage. The more important thing is, rather than using a standard rectifier diode, those usually don't have very fast response time. So if you put those in there, there is the possibility that you can still get at least a partial spike, because before that diode has a chance to react, the voltage will get across there. Whereas if you use a high-speed switching diode, like a 1N4148 or something like that, that are a little bit faster switching time, it'll actually be more efficient at clipping off those peaks like that. That's why I used a 1N4148 or a 1N914. That's an even faster one, has a faster gating time. So any of those, is good. Okay, just wanted to add that on there. Again, a 1N4007 is better than nothing. It will still, to a degree, it will do it, but the fast switching diodes actually are even a little bit better. Okay, very good. Okay, the next question I got was from one of our friends out in Scotland, and he's asking about, I do get questions like this. He has a piece of Pioneer gear and wants to do a recap on it, which is that should be pretty straightforward to do. But the concern is, what happens when some of these older semiconductors, the older transistors and so forth, fail, as we so often see. How many of my videos have you guys watched and I found a leaky or faulty transistor that had to be replaced? And the transistors and semiconductors used over in Europe quite often have different part numbers and even maybe a little different characteristics than the ones that you see over in the United States and other parts of the world, in Asia and so forth. So, how do we get around this problem? Well, that's an extremely good question. Very often, even here in the United States, these transistors are old. They haven't been made for 30 plus years, and even though you live here in the States and it was a product made for the States, you can no longer get the exact replacements here either. So what you end up having to do is you end up having to pretty much find a modern transistor that will fit in to the needs, that'll suit the need of the transistor that you're replacing. And that's not always an easy thing. Now, in a very straightforward amplifier circuit where you just have, a small signal transistor and it's providing a small amount of gain, with the exception of, the noise characteristics of the transistor, you can pretty much substitute most modern transistors for those ones. Where I seem to have the most problems is anything related to a tuner, something that's operating at a high frequency, some preamp circuits where the gain is extraordinarily tight and important. The transistor has to have a specific gain characteristic, especially the higher gain, like the HFE of 200 or better. That's where you start having to be a little more careful what kind of transistor you choose. And it's not always apparent by looking at the schematic what kind of transistor it is. Let me see if I can find an example of this. What we're looking at right now is the old Pioneer SX750. Those of you who are regular viewers of my channel remember when I did the video series on the repair of this one, we ran into a faulty transistor here. Okay, one of these was bad, and if you look, these are pairs. Now, for this particular one, you see these little dashed lines around these two transistors. This is an indicator that this is a package transistor. In other words, there are two separate transistors inside this one package, and the schematic is not anatomically correct. If you see, they're showing that these emitters are connected together outside the package, when in fact they're internally connected. So there are only 5 wires on this package, not 6. But we'll get into that in a minute. The point that I'm making is there are circuits like this out there, other amplifiers, that use 2 separate discrete transistors. Now, these aren't just any transistor that you can just pull off the shelf. You can't just get a 2N2222 or 2N3906, let's say, which is that's a PNP transistor, and just throw it in there. A standard signal transistor. Not going to work. These have special gain characteristics. They're extremely low noise and very stable. You have to be more specific what kind of transistor you choose. Now, knowing is half the battle. When you know that these are low noise transistors and you know that they have to be perfectly matched, you start to build a picture of what kind of component you want to choose for this. And at that point in time, you can go on to your, whoever your parts vendor is that you prefer. Over here in the States, there's probably 3 or 4 well-known parts distributors that are still in business that handle most of the modern production transistors out there, and you can sort through them and find something with similar characteristics. The other thing you have to watch is in some of these bigger amplifiers. Now, this is a 50-watt amplifier, but when you start getting into the high wattage amplifiers, 100, 200 watts per channel and so forth, what ends up happening is the rail voltage going into these, they don't bother stepping the voltage down all the time. They just use the high voltage that the outputs are using. It could be 70, 80 volts. They're putting across these transistors, and if it's a positive and negative split rail supply, there's a potential, if it's 80 volts, there's a potential of 160 volts that could be across a transistor depending how it's set up. So in that case, you have to make sure you choose a special transistor that's designed to handle high voltage. They make small signal transistors that have high breakdown voltages, but they're not the kind you buy in your local, Radio Shack. They're now out of business, but your local parts places. you have to, there's very few of them available out there today still, and you have to very specifically order them. So there are crossover manuals out there, but again, I'm finding that the crossover manuals you see today are not so good compared to how they used to be. Now there's another thing that I use that helps me identify these so that I can choose a good equivalent. Let me show you how I do it. Alright, so I have a website up here called NTE. Okay, NTE over here in the States, I believe that originally stood for New Tone Electronics, and they were a little bit later coming to the game from ECG, or Electronic Components Group, or some of the other ones out there, like the RCA was the SK series, ECG was the ECG series, and the NTE actually follows the same parts as ECG. So anything that's ECG number, you can substitute with the letters NTE and that number, and they'll cross to the exact same transistor. But more importantly, these companies make transistors that are replacements or equivalents to other transistors. Now, a lot of times NTE will purchase a transistor or a semiconductor from another manufacturer, and they'll rebrand it with their part number, but it's really somebody else's. The other thing they'll do is they'll take a equivalent transistor that will work in place of it, but it may not have exactly the same specs. It may have a little higher voltage rating or higher current rating, but if you plug it in place of the original, 9 times out of 10 or even more, it will work. Now, why did I bring you to this site? NTE transistors are still available. They can be ordered online, but they're not always available, and they aren't always the best component as far as quality goes. A lot of times you may want something else. But what this program does, you can go on here excuse me, and you can download, for whatever version of computer or device you have, you can download their little application, and what it does is it allows you to type in a part number, and it will cross it over to an equivalent. So let's see. So I have Quick Cross installed on the computer, and I just start it up by clicking on the icon. And if you click over to search, okay, now you can go to info, and you can actually, it'll give you some information about their website. But if you click search, this is what we're really interested in. So for instance, let's say I wanted to find I have a transistor and I want to cross it over to something. So let's say 2N3904, okay? And I click on the search button. So I type in my 2N3904 and I click search. And you can see it comes up with the different iterations of 2N3904, okay, or anything with the letters 2N or the characters 2N3904 in them, and then it will tell you what NTE component it crosses over to. Now that's all well and fine. So for instance, they're saying that a plain old 2N3904 crosses over to an NTE 123 Alpha Papa AP. And the most important thing is right next to it there is a downloadable data sheet. So if you click on that, it brings up a full data sheet that describes the characteristics of that particular transistor. Now this is a very powerful tool because maybe you may not have access to an NTE transistor, or a vendor that sells them. Or maybe perhaps the NTEs are a little maybe lower quality. Sometimes they are, sometimes they aren't, but most of the time NTE components seem to work fine for when I've used them. But the biggest thing is when we open up this sheet, it's this thing's 3 pages long, and it's got the outline of the component, the pinout, the size. It tells you all the characteristics. So we know the breakdown voltages, for collector to emitter, collector to base, so forth and so on. Power dissipation. It'll go all the way down the line and tell you everything about that transistor. Well, now that you have this information, you can print this out or write down what characteristics you need, and now you can go to your parts vendors and search through their inventory and find something that matches that. Very, very often when you see me replace a transistor, this is how I do it. Okay, I convert it to, if I can't find any spec sheets online for the transistor that I need, I'll convert it to an NTE, and then I'll find an equivalent. Okay, now you can also go go very basic, and you can just type in 2N3904, and if it's a common component, it will pop up and it'll say the word PDF next to it on Google when you Google search it, and you can click on that and it will take you straight to a data sheet. Now I did that in one easy Google search, and once again, just like the NTE, it gives you the data sheet for that particular transistor. You then go through, but what you're going to find on this is a lot of these old Japanese transistors from the old Pioneer and Sansui and so forth, especially when you get into Macintosh. Very difficult to find a data sheet for those original part numbers. But in many cases, I've found that the NTE Quick Cross will cross it over to an equivalent NTE, and you can then get the data sheet from them. Okay, so there's 2 different methods for finding it. Once again, once you know the component, then you can go to your parts vendors and search and find an equivalent. Okay, so I hope that helps you out, and I hope that answers the question. Okay, so I have another one asking about when I will be doing some more X-ray videos. Well, funny you mentioned that. I do have a couple that I'm going to be working on here. Not sure of a time frame, but I am going to do one specific video on radiation, and that's going to be a pretty involved one, because I want to, when I finish the video, I want everybody to come away with a little better understanding of what we mean when we say radiation. A lot of people think of the word radiation and you think of X-rays, but X-ray is only one form. There's ionizing and non-ionizing. There's sonic. There's all kinds of things, and we're going to get into those and kind of demonstrate what they are in a video. The other thing is I have a little ultrasound machine that I may demonstrate, and maybe I have a couple jobs coming up that maybe we'll do some on-location work, and we do have some installations coming up, so we may shoot a little bit of footage of that if we can do it. So that's the best answer I can give you. It's coming up soon, but don't have an exact date or time frame yet, but we are doing them. Okay, another one I have here, long story short, he's talking about watching some of my videos, and one of the things that he's really always wondered about has been how impedance matching works, and namely using like a balun. Now balun, for those of you who don't know what that word is, B-A-L-U-N, it's an amalgamation of 2 words, okay, which basically what it means is bal stands for balance or balanced, and un stands for unbalanced. Okay, so a balun is an impedance matching device that will match a balanced load, and boy, we're going to have to really get into that. That would be a separate video, to an unbalanced load. Okay, in terms of RF or radio or antennas, a balanced and unbalanced circuit would be, for instance, when you use a ladder line, or twin lead wire for your feed line for the antenna, versus when you use a coaxial cable, let's say, which is an unbalanced load. Okay, so I'm going to leave it at that, but there's also, if you look at, maybe if we take a look at my ham radio antenna outside, it has an unun on it. A lot of people don't hear about an unun, but what that means is it's actually balancing the load between an unbalanced, taking an unbalanced load and matching it to an unbalanced transmitter. And really all you're changing is the actual impedance. So you're matching an impedance on one end to a different impedance on the other, and they're both unbalanced circuits. So we'll get more into that, but that might be a good video to do. Okay, if I can, I certainly don't know as much. I am a ham operator. That reminds me, I got a question on that too. But I am certainly not an expert on antennas. That is such a science. It's an art and a science all in one. No matter how scientific you get with an antenna, there's so much in nature that affects it, that it's also, I have to classify it as much an art form as it is a science. It is a very disciplined science, but it's also a very fine art form to make an antenna do what you want it to do in a predictable way. But I will give you my best shot. Maybe that might be a good video. So, all right, that's that one. For the next question, or questions, I've had multiple. I put this big mess of components before you. Keep getting comments on the quasi-complementary amplifier, and let me tell you guys, it was a failure for me. Biasing it was very unstable. We went over all this on the last Q&A video. Everything was under designed, and I tried to rebuild it and improve it, and it didn't really help. So I decided I would try to kind of redeem myself. So I started looking at what's out there, and I came across this little kit that I think it was maybe $15 or $20 is all it was. And of all places, it came from Sri Lanka. Of all places. And I don't know how available they still are, and this is all that came with it for instructions. So really on your own for this one, if you're not familiar with this stuff. But the thing that really caught my attention is this. It's based upon this STK 4191 stereo amplifier IC, and this is rated at a true 50 watts per channel, and that's at low distortion, the real deal. If you look at some of the later realistic Fisher, even like the Pioneer SX 780s, they were using these STK chips. These were really great chips. This is not an IC like your chip in your computer, okay? Don't mistake it for that. This is actually a module. It is actually discrete transistors and components all formed together in one package. There's a lot of advantage to that because it allows all of the components to run at the same temperature, so you have stabilization of temperature. It's very quiet. You don't have any big wires or interconnections. Everything's direct connected. So there's a lot of advantages to these, and they were very successful for a long time. So I'm really looking forward to trying this. This is actually looks like it's a really good quality kit for the price. And this is an actual, I think this is an actual Sanyo chip. I'm not sure, but I think it is. They advertised it as such. And it just comes with the components. A couple things I really liked right off the bat was great big power diodes for the rectifiers. Not so big. Now these are supposed to be Rubicon, it says Rubicon capacitors, 4700 microfarad at 50 volts. That's a little bit too small for a 50 watt amp. But name brand components, 105 degree. I'm sure these could possibly be knockoff, but they look old. They look, I don't know. I'll have to test them. That's all I could say. But it just, I don't know. Maybe I'm getting my hopes up again, guys. I don't know. But I'm going to try it. We're going to try it. We're going to see if this turns out to be a good product for a $20 kit. I'll do a really good video of assembling it and some ideas of how to do this. And, if these are still available, maybe it'll give you all a chance to have a really good amplifier on the cheap. So we'll find out. So that's all I can say. As far as that other kit, I don't recommend it. So that's why I'm moving on. So, all right. Okay, the next comment's just a comment, but I'm amused by it. I'd like to see a Marantz Model 10B tuner in your workshop for restoration. Well, let me tell you something. However much you would like to see me have that on my bench, I would like to see that on my bench about 10 times more than that. So, yeah, that would be fantastic. Anybody out there has Marantz 10B, that would be really cool. So they had the built-in scope for looking at the multipath. They're just a really awesome thing. So, yep, if you guys definitely have anything like that, I'll be interested in doing a restoration on it. That would be a great video, I think, and it would be a lot of fun. Next thing I want to talk about is the video I did, it's probably been over a year ago or more, on how does a CAT scanner, a CT, work. It's surprisingly enough, that video has had more views than any other video that I've made on my channel. And unfortunately, when I shot the video came out perfect. I edited it, it looked perfect, it was clear and sharp. I uploaded it to YouTube, and I guess the format that my older camera was using, the video came out choppy. It was, it shuddered. It wasn't real smooth movement on the video. I deleted it, I re-uploaded it, same thing, I couldn't get it to come out right. So I probably need to re-edit it somehow with my newer editing software and try to re-upload it. But rather than do that, I have some other CTs that are even more interesting, more modern than this one, so I may do another video just out of interest. I have to make sure I can do it without getting in any kind of copyright problems. Some manufacturers of this $1 million equipment get kind of upset if you share any information. I mean, not that I know any proprietary information, but it's stuff that anybody could know by just going and looking at it. But yeah, I'll do another video on CT. Like I said, I'd like to show you all a little more of what I do for a living, because it really doesn't have anything to do with audio, really. So yeah, maybe I'll do that. But I apologize for that video. It is an interesting video. I like it, but it's too choppy. So we need to get an updated version of that. All right, another really good comment that I owe you all apology for, and I'm glad this viewer brought this up. you have to watch the kind of cleaning agents that you use on vintage equipment. Different manufacturers use different methods for putting the the lettering and numbering and markings on the faceplates of their gear. And some modern cleaning things like Simple Green, under the right circumstances, it'll immediately take the lettering right off of something. You have to really know. Always test any chemical or any cleaning agent on an inconspicuous place of the faceplate or whatever before going for it and cleaning. And the other thing is, if it's just dirt and grime, it's not little heavy grease or some sort of paint or markings you're trying to remove. A lot of times, just warm water, maybe a little bit of very mild dish soap at the most, and a soft cloth will work wonders. The warmth of the water will soften up the dirt and allow you to wipe it down pretty easily. So, thank you for that comment. That actually, I meant to say that, and good catch. Be careful, guys. Next one's another good question, and that was that on a lot of my videos, when we get to the part where we're testing the output of an amplifier, of a stereo amplifier, you often see me connect a signal generator that's a 2-channel signal generator, which is the Rigol DG4162. And I'll show it to you if you don't mind getting a little bit of vertigo. But there it is. Okay, let's go back in the holder here. And I use the 2 output channels to drive the left and right, and I can independently change things, outputs and frequencies and so forth, but it's not entirely necessary to do that. The other thing is, if it's not a good quality signal generator like that one is, you can't always guarantee that the outputs will be perfectly matched. When you're measuring outputs of the amp, you want to make sure that the inputs are the same. So the viewer's asking if it's possible to just split a single output generator into 2 separate outputs and connect them, feed them together in like a mono signal. And absolutely you can. Basically what you want to do is just come out of your signal generator and you want to go into a couple of resistors. The resistors are going to really be dependent upon the input impedance of the amplifier. You just want to kind of present that same kind of impedance on there so you don't induce noise or anything like that. The other thing is, when you start messing around with that, you want to make sure you can measure with a scope what's going into the input terminals on the other side of those splitter resistors, so that you can get your input voltage correct. If you're really worried about measuring the gain of the amplifier, because you have to have an accurate input voltage to be able to compare it to the output voltage so that you can get the actual gain of the amplifier. But again, most people don't do that. You just want to feed a sufficient signal into it so that when you crank the volume knob up without maxing the volume knob, you can actually get your maximum output, drive the amp into clipping. Okay, so yes, you can absolutely do that. You don't need a really high-end signal generator. A basic single channel audio frequency generator will work just fine. Okay, the next question is about where I got the new, on the last Q&A, or one of my videos, the Pioneer SX525, I showed you all a new sliding camera mount that I have on my bench, and really it came from a couple different pieces. The first part, and again we're going to have to go mobile on the camera, the first part is this clamp right here, this clamp assembly. Okay, you see it? This actually, believe it or not, this is an IV pole holder that you use on the side of a table in a hospital, and you can put the IV pole in there and clamp down on it, and it will hold the IV pole, because they're removable. Like on cardiac cath labs and things that you'll see this. So that's what this front part is. This back part is off of a wall mount computer mount. So it actually, there was more to it than just this track and this one slide. There was two slides on this track. One held a like a boom arm, like an arm that would hold your keyboard and your mouse. It was like a little platform thing. And the other one had a little VESA mount bracket. It was just another slider like this so that you could mount a monitor. And the idea was you bolt this the opposite, not side to side, but you bolted it up and down, vertically, and it would allow you to mount your monitor above, and then below it you had the keyboard and mouse bracket, and they were height adjustable. And we use those in hospitals a lot for the digital rooms and things like that to to get things up off the floor and off of the desks and things, keep it nice and neat. And I pulled out a system that had one of those, and I just didn't have the heart to throw it away, so I kept it. I'm kind of a pack rat, I kind of repurpose things when I find them. You wonder why the price of healthcare is so high, and it's because such nice stuff so often gets thrown away or recycled so frequently, things that aren't even that old. It's kind of a shame, and I just don't like to see those things go to waste, so I try to repurpose them. So that's where I got it. Alright, the next question deals with capacitors. When you replace, when is it okay to replace electrolytic capacitors with film capacitors, let's say? Well, in most cases, as long as you can find a suitable film capacitor that isn't too big or too expensive, it will work in place of electrolytics. Now, you're not going to find a 30,000 microfarad film capacitor, and if you did, it would be the size of a car. But in some instances, I've seen high-end tube stereo gear where they have 600 volt film capacitors rated at maybe 8 or 10 microfarads or so, that they use in place of the main filter caps for the, and they claim that it makes the amp sound better or whatever. I don't know about the sound. What I do know is that it'll sure last a lot longer. Electrolytics, they have a lifespan and they wear out. They go bad. Even modern ones will go bad eventually. But film capacitors have a much longer life expectancy. They're more stable. They're not as susceptible to temperature variation and things like that. So they work really well, especially when you're using them in the signal path. A lot of that 1970s vintage gear, they used electrolytics in the signal path. So you have the actual sound going directly through that capacitor as a coupling capacitor. And they're special, they're different, they're low noise, low ESR electrolytics, and more expensive they are, but still a better option in my opinion would be a film capacitor. I've used them many times on vintage, good quality vintage gear, and I've always, at least with my bad hearing, I don't know if it's a placebo effect or what, but to me they sound a lot better. They open the sound up more. The highs are a lot better. When you hear a cymbal or something, it just has a much clearer sound. That's my opinion, though. Where you don't want to substitute capacitors is in a tuner, not the audio path, but in the tuner path. Anything that's involving the oscillator or the IF or anything like that, stick with what's in there. If it's a film capacitor, replace it with a film. If it's a ceramic capacitor, replace it with a ceramic, and make sure it's the right type of ceramic. There are special ceramic caps called NP0, and what that means is that they don't change their capacitance with respect to temperature. They're way more expensive than a normal ceramic cap, but they're very stable and they work very well in oscillator circuits. If it's a mica capacitor they're using in an oscillator circuit, replace it with a mica. Do not try to replace it with a ceramic. Never substitute capacitors in tuners unless you know what you're doing. In the audio path, like I said, that you have some leeway with that, as I discussed, but beyond that, that's my advice, at least, and that's been my experience. I've tried doing things like that just to see, and it doesn't usually work out too well. Put the right kind in. Okay, I got a lot of confusion on the Pioneer SX525 video concerning the output coupling capacitors that drive the, between the output section of the amp and the speakers. The speaker capacitor in that type of design is designed to isolate the DC from the speaker, and maybe the way I worded it was misunderstood to say that there is no DC on the capacitor. That's not what I mean. What I mean is that you don't, on other types of designs of amplifiers, you actually have a balance adjustment, like an offset adjustment, and the idea is that you adjust this pot so that the bias of the push-pull transistors are set equal, so that that at the center point where they meet together, where you would normally connect your speaker, there is 0 volts at idle. There's 0 volts DC, and the only thing that ever comes out of there to the speaker, as far as the speaker is concerned, is AC. Okay, unless there's a problem, and then the protect circuit will shut it down. In this particular circuit, it's the way the bias is set. There is voltage at that junction point of the transistors all the time, so you need that transistor or that capacitor to isolate that DC from the speakers. But what I was trying to say is that because you have that capacitor there, you will never see DC on your speaker terminals, and therefore that's why you don't really have the DC offset adjustment like you would have on the other types of amps. So I hope that kind of clears up what I was trying to say. But yes, it is true, there is voltage on the one side of the cap of DC, but on the speaker side there is not. It's not DC. Okay? Okay, the next one is from Mike over at Mike's Radio Repair, and he's one of my go-to sites that I go to. I highly recommend you guys check out his website. He's a fantastic engineer, wealth of knowledge, and every time he does a video I learn something new. So I really appreciate that he even takes the time to watch my videos. Compared to what he knows, I'm sure there's not much I can offer to him. But anyhow, he made this comment, and I thought I'd share it with all of you because we were talking about the variable adjustment on the oscilloscope for the horizontal and vertical, and he mentioned something that's really important that I didn't mention. The variable adjustment is a valuable tool. Many transceiver alignment procedures call for setting the output power to something like 1/3 or 2/3 of the measured signal, and with the variable control you don't need to do any math. If you need 1/3, you use the variable control to adjust so the waveform just fills 6 divisions. And now adjust the power of the transceiver and fill the 2 divisions, which is 1/3. So what he's talking about is that you can kind of shrink or stretch that signal to fit in the amount of graticules you need, and then you can just count the graticules rather than trying to figure out 2/3 of this many volts is this fraction of this amount of graticules. You just set it to an even number of divisions, and then you can count divisions rather than counting volts, or count counting time frames. It is a really good tool for that. So super duper comment. Thank you, Mike. I appreciate it. Another scope comment is on using some of the measurement functions of the oscilloscopes, like the frequency counter and the OON and some of the other low-cost name brands out there. Do they have that function? And yes, they pretty much all do. One word of warning I'll give you is the frequency counters and things like that that are built into an oscilloscope are probably not quite as accurate as a standalone high-end frequency counter. Just so you understand that. I mean, for most of what all of us are doing out there, it's fine. There's no problem. But just understand, if you're looking for high accuracy, go with a standalone frequency counter, an old one that's really good and well calibrated, or use a spectrum analyzer. That's really the best way to get good frequency measurement. But the ones built into the scopes today are pretty good. Even on the cheap scopes, they work. Okay, there were quite a few other scope questions. I can't cover all of them because there's so many, but they deal with, XY mode, connecting it using an isolation transformer, scope safety. I think the best way to handle it is I'm going to do a follow-up scope video for scope safety and some things about using probes and things like that. So stay tuned. I'll try to do a little video on that. But I'm going to end up with this last question, and it is, I take it you never try reforming the capacitors by slowly bringing up the voltage while monitoring the current. Well, I do that to an extent. If I'm testing something out on a variac and I just want to get a baseline of the functionality of a piece of gear, like especially an old radio or something, a lot of times I'll bring it up slowly, and sometimes you can do that, and an electrolytic capacitor, will what we call reform itself, which means the chemical reaction, the electrons flowing through that capacitor, will cause the chemistry inside that capacitor to reactivate, and sometimes it'll bring the capacitor back to life. It's acting as a resistor or as a short, and it does produce some heat while it's doing this, but eventually the capacitor will, what we call, reform. It'll start acting as a capacitor again. I will do that in order to test something, but I typically won't leave the capacitors in. If they needed reformed in the first place, depending how bad they were, I'm probably not going to leave it in there, and I'm probably going to replace it eventually, just to future-proof it, so I don't have to come back later. Now, if it's a brand new capacitor but's been sitting on a shelf, the chemistry may have settled a little bit to where it needs reformed, maybe I'll do it in that case. But for the most part, I typically don't try to reform capacitors and reuse them for what they cost. Now, some caps are very expensive. Maybe I would try that in that instance, but for what they cost today, I just replace them. So that's again just my practice, my opinion on that. So I hope you all enjoyed this, what ended up probably being a pretty long video. I hope I answered all of your questions. I just can't thank all of you enough for the wonderful comments and all that. I appreciate them, I really do. And so that's going to be a wrap for this video. I have a whole bunch of little radio projects just for time wasters. When I want some mind numbing, I'm probably going to start doing some of those. I have that little amplifier I'm going to build. I'm sure I'm going to have some more gear coming on the bench to be repaired. Probably going to be doing some more X-ray and ultrasound and radiation video type things. So stay tuned, lots to come. And once again, thank you all for subscribing, for watching, for the good comments. This is just so much better entertainment than anything I could ever see on television these days, especially with what all goes on. I really, it's a lot more calming to watch these kinds of videos than to some of the stuff you see out there today. So that's my little soapbox. That's all I'm going to say about it. But anyhow, I thank you all. You have a wonderful day, and give me a thumbs up if you liked what you see. Comments and questions are always welcome. And I wish you all peace and health and joy in your lives. And don't keep the faith, share it with others. Oh, and I just wanted to give one last thing. My wife and I have been kind of dealing with cancer a little bit with her over the since April. She's had her last chemo treatment last week. It went really well. I think we're going to have a full recovery here, so I'm very thankful and grateful. And I just thought I'd share my happiness with all of you and let you all know that. And yep, just wanted to let you all know. Thank you so much. Take care.